Hi, and welcome to this video from the algebra section, and in this video we're going to have a quick refresh of coordinates. So, here we go. So coordinates are just a way to be able to describe the location or position of a particular object. And they're invented way back in the 17th century by kind of this guy, René Descartes, so they're sometimes called Cartesian Coordinates, and he was like kind of just an all-round kind of mathematician, theologian, general egghead. But let's say he was the first guy that came up with this idea of being able to describe location or position in this way, and it's a really simple idea. So we've got a set of axes. There's our x-axis, there's our y-axis, and all we're going to do is just say, well, can I identify the coordinates of each of those locations in the UK on that grid. So let's start off by defining this point here, which is the origin. So everything is going to be described relative to the origin. So the coordinate for the origin would be 0, 0. Because we haven't gone anywhere on the x-axis, we haven't gone anywhere on the y-axis, it's where they meet, so that's 0, 0 there. And then what we're going to do is just essentially describe how far across and how far up we are compared to the origin. And as I said, the first number in our pair is the x-coordinate. So there's lots of different ways of remembering it. A lot of people say, well, x across, or as in x is across, or some people will say you go kind of along the corridor and then up the stairs. So along the corridor, basically meaning we go to the x one first, and then we go up the stairs, which is the y-axis. So here we go. Let's have a look at London. So to get to London from the origin, or the location of London compared to the origin, is just 5 across, 2 up. So our coordinates are 5, 2. And the 5, that's called the x-coordinate. That one is called the y-coordinate. Okay, Edinburgh. So if we go for Edinburgh, that's across 3, up 6. So that's at the point 3, 6. Penzance, yeah, is 2, 1. And then finally Birmingham, which is at 4, 3. And there we go. Let's just extend that idea a little bit further, and now let's draw a grid that includes negative numbers. So there we are, there's a grid with a trapezium on it. You can see the origin is there in the middle. Again, it's at 0, 0. But now it's basically at the middle of those two sets of axes. So essentially you can see each axis is a number line. If you imagine the x-axis, a number line going from positives from 4 down to 0 and then into minuses. And the same with the y-axis. It's essentially just a number line going up and down. So the coordinates for each corner of the trapezium. So if we have the first one. So A, if I'm at the origin here, I haven't got to go across at all, so I'm just going straight up. So my x-coordinate is going to be 0, my y-coordinate is going to be 1. For B, that's going to be across 2, up 1, so that would be 2, 1. C is the first time we're going to use negative, so we're going across 4, but this time we're going down 2, so we're at minus 2 on our y-axis, so that's 4 minus 2. And then for D, we're going backwards into the negatives for x, so that's going to be minus 2, and the y-coordinate is at minus 2. Okay, and here's a question that'd be similar to what you might see on your test. So we've got some squares being put on the grid. So we've got a square that's 1 unit, here's a 2 unit, and 3. And we've got these blue dots. And the question we're going to get asked is, what are the coordinates for the blue dot or the blue circle for square number 5? So if we imagine adding on another square down here, and then the 5th square would be right off the bottom down here. So we're not going to do this by drawing it, we're going to do this just by thinking a little bit about the pattern and how far we're moving across and down from each blue dot. So let's kick off with going from square 1, so from this blue dot here to square 2 to that blue dot there. So I've had to go across 2 and down 2. So if I started here at minus 5, 3, I'm going across 2, which takes me minus 3, going down 2, that's going to take me to 1. We can see the point here is at minus 3, 1. Same deal going from the square 2 to square 3. So this time we're going across 3, down 3. And again, we can see we're going to end up, we can just read the coordinate off. That's going to be at 0, minus 2. Now, this one I'm not going to draw out, but I know if I put the next square on, it's going to be side 4. So it's going to go across 4 and down 4. So from this point here, if I go across 4, so let's go 1, 2, 3, 4. And I'll go down 4, 1, 2, 3, 4. There we go. I'm going to end up there where my cursor is there. So that's going to be at 4 minus 6. And then for the last one, let's say I can't count out on the grid, so I'm going to have to look at the coordinates and say, well, to go from square 4 to square 5, we're going across 5 and down 5. So let's have a look at this coordinate here. From square 4, I'm at this point here. The x-coordinate is 4, so if I go across 5 units from there, I'm going to end up at 9. And for this one, if I'm at minus 6, I'm going down a further 5, going from minus 6 down another 5. I'm going to end up at minus 11.